This is Charlie Yu, and today I'm going to talk about case-based reasoning for Go. Let me introduce the game first. Go is an ancient strategy game started from China 2,500 years ago. It's mostly played by the highly educated ones. It's called talking through hands. And by playing the Go, you can see the other side's intelligence, like personality, sometimes even their aesthetics. Like this one is the really famous game, the century, like game of the century from Wu Qingyuan and Honimbo Shusai. They're the like Wu Qingyuan was 18 years old, which kind of a genius, and Honimbo Shusai was the most powerful Go champion at the period. Anyway, let's go back. The rule is very simple. Like the players take the turns, and whoever get the biggest territory wins. But to get the territory, you have to make sure you're not killed. And that's what we're going to do. Like we're going to recognize the death and alive situations. And it's 19 times 19, 361 possible position, 10 to the 170 possibilities. That makes it really good for AI training because it's so complex. And I chose that because it's about pattern recognition. For the beginners, the patterns is like the graphs that you need to recognize. So I thought it would be a good project for the case-based learning, but it turned out it's probably I didn't get the correct features, but it's not so successful. So our topic today is about the Left 4 Dead puzzles, Tsumego. Like you can see, those are usually the corner cases. Those are the two survived corner cases for the black. Like you can see, if the white tries to attack the black here, the black only needs to move here, make an eye here, which means the white cannot put there because it will run out of the liberty. And here's another eye, because the white put here, the black can easily kill it within it. So that's what I'm gonna do, like how to recognize the eyes and how to make it survival. So there are many classic patterns, and it's a critical skill for the beginners, actually for all the way to the master. So here is our case-based reasoning. We have to retrieve, find similar cases, which is really hard for the harder puzzles. Here we are using cosine similarities for the board vectors, Hamming distance for the pattern, like shape. Weighted templates is for the corner case, because the corner, like how closer to the corner, is really important. Like first road is called the death road, second road is called the crawling road, third road is called the survival, and the fourth road is called the potential. And the liberty is like the possible moves around the stones. Like for this one, it has 1, 2, 3, 4, 5 liberties or breathing around it. So for this one, like we need to do the feature extraction in order to do the KNN. Actually, turned out the KNN is not so successful. Probably it recognized the surface pattern, but not the logic underneath it. I extracted the stone position, and turned out I used only the left upper corner for the game. And the liberty counts. The breathing from each side is really critical in the life and death situation. A tally detection, like groups with only one liberty, and eye shapes, how to make it. And there's so many challenges and limitations. I first wanted to use the gopuzzles.com. They have the API for all kind of the Sumeco puzzles, and it turned out their puzzle is so advanced. The recognition is not so successful, because it can only catch the surface similarities, but cannot find the logic behind of it. It's really hard to find the logic through like the analysis we just talked about. And transformation invariance, that's another thing. Sometimes they look so different, but actually they're the same puzzle. Like the one on the corner and the one on the edge is actually the same logic. And finally, the capturing strategic intent. Like sometimes you need to make a sacrifice to catch them all. But for the algorithm, it's really hard to tell if it's a sacrifice or a suicide. Sometimes it's just a suicide, which is not so good advice. And here's the code. Again, we're using Streamlit, and we're extracting the features, calculate all the similarities, And here's all our similarities: cosine Hamming weighted liberty. And this is the weight. Like, I'm trying to adjust it, but turn out, again, we have so few cases. And then here's the naive cases we have, basically for the kindergarten students, because it can, like, once the logic became like too complex, it cannot really get what is happening. And here's the UI part. Let's see. Here's one. Let's start over. So here's the library we have, the classic ones. Like this one, you can see if you put the black stone here, the white has to kill itself in order to kill the black in the center. Similar thing with the black 3. Like if the black puts here, it has to kill itself. This one is a really fun one. Like the black has so many breaths, but if the black wants to stop it here, it only has 2 liberty, which means the white can easily kill it. So the black has to go here, and if the white go extend, the black jumps here, it will kill it, which is going to be like really fun. And here's what we call the sacrifice. In order to kill the white here, the black has to put the stone here, which has only 1 liberty. The white can easily kill it, but by doing that, it's only going to be 1 liberty by itself, and the black can kill it right here. So let's see how well it goes. Trust me, it's not so good. This is what our teacher called like a suicide, because the white can easily kill it. Like right here. Put it here. But right now we're trying to test this, gonna find the similarities. So if I put it here, that's actually gonna be something like the Atari Escape, or it's going to be a Carpenter Square. Yeah, it catch the Carpenter Square. Why that? Because by doing that, we need to extend it and we need to catch it through the jump. Let's see if the black continues. Okay, it goes back to the Atari, which is actually correct, because Atari and the Carpenter Square are the closest we have about it. Okay, Carpenter Square again. It's running for its survival. Nah, no, this is not the case. Again, the best one still is the Carpenter Squared, and which is the cosine similarity is running. Like you see the logic is actually still the same. For the Carpenter Square, if the white in the center crawling out, the black have to jump here. It's for our case, it's like the black is crawling out, the white has to jump here. So the logic is the same, but the pattern is becomes so different because this is a straight line now. Yep. And that's it. Thank you very much. Hopefully you enjoyed that. Thanks, bye.